And this has to do with gears. Okay? At some point, and this is all leading up to I'm sure you guys got that email that I sent out Friday morning where I said, hey, I want you to go out, figure out some kind of a game process and design something. And then I figured out, wait a minute, I really haven't given you all the tools. This is really kind of the last set of tools that I want to try and give you guys, um, as far as being able to at least get started on that, which is how do we model movement inside SolidWorks? And then, more importantly, how do we model movement that I can actually make happen in the physical world on my robots in FTC? Okay. And we're going to get to all of that before the end of the night. So the other thing, like I said, I wanted to show you is the gear mate. So if we look at, and in fact, at this point, I'm going to bring up a component from our robot last year, just as a beginning of the demonstration here. Open. Cliff gripper. All right, so nice little wizard aside. Um, this was our gripper. And the way this is modeled inside SolidWorks, if you turn any one of these gears, you can see all of the gears turn. And they're turning in their appropriate direction. So how do we model that in SolidWorks? And what I'm going to do is I'm going to actually just bring in a channel and just bring in some gears. What size gears are these? These are 48 tooth gears. Fantastic. So I'm going to bring in a channel. The channel is just going to give us these big holes because the gears are actually physically attached to shafts that run through bearings that are actually mounted to the big holes. Well, in SolidWorks, again, I'm just going to take the shortcut of we're going to take the gears and mate them to some big holes so that we can see the basics of the gear mate. So let's go in. Let's go ahead and close this so that it's not dragging down my system. And let's create a new assembly. And let us bring in my server. All right, so what did I say? A channel. Let's bring in 6-inch channel, should be long enough. And let's bring in some gears. And John, do you remember what size gear I said I was using? He's probably muted his microphone.
42.
48 tooth. So if you do end up coming out here and you start looking at some of these files, especially with the gears and with the sprockets, you should see some number with the letter T, and that is the number of teeth on the gear or on the sprocket. The 32P, that is what they call the pitch, and that has to do with how many teeth, how many teeth per inch. And you can go on Servo City's website and look a little bit more about that. But we're just going to bring in two 48 teeth gears. So we're going to add a channel. I'm going to flip it over. And then I'm going to add a gear, lay it down this way. And another one. Now the reason I brought in the 48 tooth gears, you will actually see if we go out on the ServoCity website, and I just do want to take just this second to talk about this for a minute. If you go out on the ServoCity website, it's neat. They actually explain with let's go this way. Motion components, rotary motion, gears. So these are hub mount spur gears that we're dealing with. The point is you do need to mount these on a hub, and then the hub connects to the axle, and that's how you're making the movement. So these are hub mount gears, and these are 32 pitch gears. And these are aluminum 32 pitch gears. So where is that page? Right here. They go through and talk about what the pitch means and all that stuff. But what's really cool is this right here, this tech tips. They're telling center to center distance. If your center to center distance on two gears is 1/4 of an inch, the total tooth count, so both your gears together, has to be 48 teeth. If you are mounting 1.5 inches away, then the total teeth has to be 96. And if you are 2¼ inches away, your total teeth has to be 144 teeth. So this means if I take a, what did I grab again? A 48 tooth? Yeah, 48 tooth. So if I grabbed a 48 tooth gear and I'm trying to make this kind of a distance in between, you know, the distance marked by C here, I can do the quick math and say, well, a 48 tooth gear plus a 96 tooth gear will span this distance. And we'll show that in just a second. But there's something else there that I know then, which is my 48 tooth gear is going to spin 2 times around for every 1 time my 96 tooth gear will spin, right? So let's start off by just modeling this, okay? We are going to, for the sake of making things easy, we're going to mate both these gears coincident to the face of our channel. And then I am going to mate this gear on this hole here, and I'm going to mate this gear onto this hole here. Again, this is not what it would look like in the physical world. Physical world, I'd have to have a hub, an axle, bearings through these holes, all that. But I am just, for the sake of showing the gear mate, taking things nice and simple here. So right now I've got the 2 gears, and as you can see, they can both spin freely on their given holes, right? I want to make a gear mate now. I want it so that when I spin this gear in this counterclockwise direction, this gear will then spin in a clockwise direction. How do I make that happen? Well, I make that happen through the mechanical mates, and I select the gear mate. Notice at this point I am doing that before I have selected any physical or any features on my parts. I believe you can do this by selecting the features first, but when I start dealing with these mechanical mates and some of these more advanced options, Personally, I feel more comfortable going through it in this manner. Again, play around, find out what's most comfortable for you. You might be more comfortable doing it a little bit differently. Now, the question is, what am I selecting? On the gears, I need to select two faces that are cylindrical, or even if they're circular, I could select like this edge here if I wanted to, but I like selecting faces where possible, where I can. I need actual circular faces, so I cannot select the teeth. I can't come over here and do anything with the teeth. I've got to do something on that's a circle, and that's just how SolidWorks knows what to spin. So I'm going to select this outer circle here, the inner circle, or the inner face of the gear. Select the same corresponding spot on the other face, and I'll tell you about this ratio here in just a second. But now when I click on OK, I have actually made my mate. And now when I turn this counterclockwise, my other gear is going to spin in a clockwise direction. So nice gear mate. So when you set up the mate, it does automatically select a ratio. Now, SolidWorks is very good at this. All it has done is it has gotten the actual circumference of the circles. And you can leave that as long as you are selecting two corresponding parts on the gears. But I find it more useful, and it doesn't matter that this is going to stay at inches. I like putting in the number of teeth. If I put in the number of teeth, even though it's saying 48 inches to 48 inches, it's saying 48 to 48. Okay? And at this point, it's doing the same thing. It is giving me that one-to-one spin. So if I pick a point on this gear, and if I rotate my other gear 180 degrees, the other gear should also rotate 180 degrees. Okay? Let's look at the other scenario that I talked about from over here, which was, what if I'm setting up a 48 tooth gear with a 96 tooth gear? So what I'm going to do at this point is I'm going to go ahead and get rid of one of my gears. And SolidWorks is going to tell me, look, you're going to get rid of all of these mates that you set up, including that pretty gear mate. And I'm going to say yes and cry a little bit. Now I'm going to go insert one of my 96 tooth gears. I don't have a 96 tooth gear. For shame. Why don't I have a 96 tooth gear? They don't have a 96 tooth gear. Well, that's going to make things difficult. All right. If I want to set these things up, see what they do have. So they have got a 64, 48, 72, 76, 80, 84. So if I'm going to go 144 total teeth, I can do 80 and 64, right? Who's quick with math? What's 80 plus 64?
144.
80 plus 64 is 144. If I'm going to go 2 1/4 inches away from each other, which these two holes would be 2 1/4 inches away, then the 64 tooth and the 80 tooth gears should give me that proper diameter to have that spacing. Let's see if SolidWorks, Service City, Now, let's see if Servo City knows what they're talking about. All right, I'm going to delete my other gear. All right, so I want to bring in a 64 and an 80 tooth gear. I've multi-selected. Both of those are coming in. And something I rarely do, I'll actually let it do, because I'm just going to drop one of each of these. So I'll drop the one. It disappears from my list. I drop the other, and my list goes away. I very rarely do it that way, but I thought I would this time.
I do it that way all the time. But you did it that way as well. Oh well.
Gotcha. I don't. I usually like to keep that dialogue up and then say, okay, I'm done. But again, find out what works for you. Just because the methodology is what I like to use, you guys need to make SolidWorks your own. And I'm glad to hear, Michael, that that's something that you do it that way. All right. So
I do the same you do.
you do it typically more like I do?
Yeah, because I feel like if I'm putting something down and then I remember I need another one of that something while I'm putting them down, I like having the option of doing that.
And that's kind of my feeling too. Michael must be just he plans things out better. I think that's what it is. I just don't plan it out that well. Now, by the way, you know, I was looking specifically at these gears. There were some other options if I were to go into the smaller gears, the pinion gears. And those gears are definitely available to you. Those would be gears that you would typically mount like on a servo to be directly acted upon by a servo, but we'll get into that a little bit later if we need to. All right, so what they're saying here is 1, 2, 3, 4. So 2 holes should be in between. So if I mount this one on this hole right here, I should be mounting this other gear on this hole here. Agreed?
Agreed.
Yeah.
All right. So let's see what happens here. So we're going to mate. We're going to mate you onto this hole here. 1, 2, 3, and mate you on this hole here. And look at that. They line up perfectly. Just like Servo City said they would. Now, what do I want to do as far as the gear mate is concerned? So I come in here and I do the gear mate, and I select this face, and then I select that face. Again, SolidWorks has calculated the diameters of these circles. But is that truly giving me the ratio that I need? These circles aren't what's actually touching and giving me what I want. Instead of letting SolidWorks use those circles, because I could also set up this mate using these circles on the inside, in which case it looks to SolidWorks like it's a 1-to-1 ratio. And we know it's not a 1-to-1 ratio. So what have we got? The big gear is what? 80? What was it? 80 and 64?
I thought it was 84. Yeah, 84.
No, it's 80 and 64.
I think it's 80 and 64. So 80.
Yeah.
And you can see I've now got the visual reference here that's telling me this is the gear that I've changed. This is now set up. Teeth per diameter is 80. And come on. Why isn't it allowing me to select the other one? There we go. And the other one is 64. And you can see it's changed that one to 64. Now what I should get is, as I rotate this one a little bit, this big one should rotate more or less?
Less.
Less.
So I'm going to give this thing about 1/4 of a turn. And there's 1/4 of a turn. And you can see at 1/4 of a turn, this was pointing straight up. This hole right here was pointing straight up. So this top gear has turned a little bit more than 1/8 of the way. And I'm sure we could calculate the ratio and figure out exactly what that ratio is. Actually bring it down to like a, 2 to 3 or something like that to calculate out the ratio. But we want to do
It's a 1.25 to 1 ratio.
1.25? Must have a calculator handy. So, for every one spin, let's see. For every 1 spin on the big gear, I'll get 1 1/4 spin on the little gear.
Yes.
Okay. And like I said, you definitely want to do that. You want to give SolidWorks, you want to tell SolidWorks exactly how many teeth you have, because you do not want to, like I said, if we let the inner diameter of these circles, of this circular edge here, if we let that be the driving face. In fact, let's do this. Michael, you said that was 1 to 1.25, right?
Correct.
Let's go in. Let's delete this. And let's set up the mate again. All right, Michael. Take 2.322 and divide it by 1.822.
It's, sorry. It's 1.27.
1.27?
1.27. 1.27442371.
Okay, so 1.27. Once again, we're kind of we're not getting exact, but we can see it is off. It is not that 1.25 ratio. So if we were to allow SolidWorks to set up the ratio based upon these two circles or these two features, these faces that I've selected, it would be close, but it's not exact. And where we can, we would like to be more exact than guessing. Okay?
Mm-hmm.
All right, so I'm going to stop this video.